Hello. I'd like to go over an example of an n array tree in C++. Essentially, this is just a regular tree, but a tree that we're able to add more than just two nodes to it. So in all the previous trees I've been showing, it's just two nodes, um, and two other nodes within those nodes. But this tree uses a vector instead. A vector array instead to hold the nodes. And then these nodes also have a vector array within them to hold more nodes. Um, uh, so yeah, that's essentially what an n array tree is. I didn't know what the heck an n array tree was before like 2 days ago. Um, but yeah, I ran across a leak code problem that involved doing using an n array tree, and I just decided to look into how it is and how it's done. So I'm using uh the way that LeetCode defines an array tree. So if you have a problem, take it up with them. We're gonna start off by saying class node, integer value. We're gonna pass in a value, and then first off, we need to include a vector because that's what's gonna be holding all our children nodes. Um, std vector. And this is going to be a node, pointer node, so it's going to be pointing to the actual value of um, the nodes within our children vector. So children. Um, yes. So now we're going to create a couple methods real quick. So we're going to say node. This is going to be an empty node, so just we don't have to pass anything into it. Uh, node integer value. So we're going to pass in a value and then put that value into value. And then node integer value vector node pointer, same how we have it here. Um, not reference pointer. Children. Uh-oh. And then value children underscore children. Um, so yeah, that's essentially all we really need for the node class. So we're just adding a integer value, and then um this node class is going to have a vector of children within it. And then this is just for when we create a node. If we create a node with nothing in it, we pass nothing in it. If we create a node and then put a value in it, we just make this value into the value that we passed. If we create a node with a value and then vector of nodes, we pass the value into value and then the vector of nodes into nodes. Vector of children with into children. Yeah. So now this is just the node class. I'm now going to create the actual tree class that's going to handle all of this. So we're going to say class tree, like I've done many times before. Private node pointer root. And then I'm going to go over two ways to add nodes. So just a single node. So if the root is null, we just pass if root is equal to null, we're going to pass if we want to add one, we're going to just make root equal to one. If root is currently full and we just want to pass in one node, we would just pass this into the children vector of one. Say if we want to add a two again, we would add two to the children vector of one here, and so on and so forth. So that's one. That's the add single node. It's going to be called add void add single node. And then we're just going to pass a node, pointer node, and value. We'll take care of that in a bit. And then I want to add another one where we're going to pass in a parent. It's a P, a parent, and a child value together. And then search the tree, and wherever the parent node is found, we're going to add the child to it. Um, again, if root is null, pass in the parent value for the root. So root is equal to the parent value, and then just add the child to that current parent value's children vector. Um, for the for this for that adding of the node, we're gonna say add child node to parent, and we're gonna pass in a node pointer, int parent value int child value. So this is we're gonna pass in our current node, um, our current parent value. So search for the current parent value and then add the child value to the current parent value. Um, so add a semicolon there, and then let me say public here. Okay. So for this one, all we really have to do is just recursively call add node and then the value there. Nothing too special. It's going to be recursively calling um later in I'm going to show you it's going to be recursively calling the root node and then just adding the value to the root. So that's essentially all it's doing, just adding it to um the main root. So for this one, what we're going to say is if node equals null pointer, just return. Um, else we're going to say if um, parent, I spell parent value is equal to our current node's value. What we're going to do is go to node, that node's child vector, and then push um, a new instance of node, and then pass in the child value into it. So essentially, um, what this is doing is, um, so say if we find the parent value, so let's say 1, 2, 3. Say our parent value is we're going to add in um, a 2 and a 3, 2 for the parent and 3 for the child. What we're going to do is we're going to search the tree until we find the parent value, which is here, and then push, remember, because this has a vector of children within it, because this 2 and 3 is a vector within, is a vector of children within 1. So we're going to find 2 and then push a new node value. So 3 is going to be a node right here, a node. Push push 3 into the vector of 2, and now 3 is going to be a node vector, which then also has a vector of its own to add more children to itself as well. So that's essentially what this is doing here. And then we're going to say for um, node child within the current node's children vector. Just add child node and then pass in child parent value, same parent value, and then child value. So what this is doing, it is recursively calling, then gonna call onto the children of the children of the children of the children of the children until it can't find the value no more. Uh, so say here, if we have, just as an example, 3, 3, 3, 3, 3, 3, 3. So, or actually, let's say three, let's say 4, 3, 2, and 3. So say for this one, um, everywhere that there's a 3, we want to add a let's say we want to add a 5. So we would pass in 3 as the parent node. So search for 3, and then if we find a 3, pass in, push in a 5. So what we do is um this for each loop is checking in order, because remember that 2, 3 is in a vector. This is index 0. This is at index 1. We would start off from here, from this one. Check uh so we would pass in the main root 1, parent value of 3, and child value of 4. Check if node is null. 1 is not null. We don't do anything. Is the parent value, so 3, equal to the current node's value? No, so we don't have to push anything. Then we enter the for each loop. So we're going to check each of the uh each child node within the vector. Starting off with 2. Then we pass in 2 into the node here. We're still passing in 3 and 5 for the parent and child value. Is node 2 a null? No, it's not. We don't return. Is the parent value equal to the node's current value? Is 3 equal to 2? It is not. Then we can check the vector within 2 by passing in then we check 3. Yep, we pass in 3 right here for the child. Still passing in 3 and 5 for the parent and child value. Now we're passing in 3 here. Parent value of 3, child value of 5. Is the current node null? It is not. It is a node 3. Is the parent value equal to the current node's value? 3, which is the node's current value, and 3 is equal. So we would push into this vector. Remember, because 4 and 3 are within a vector of 3, we'd push 5 into this new vector, 5. So now this three's current vector is 5, 4, and 3. Now we want to check the nodes within this the children nodes within this node. So we would check the vector within this node. Check 5, there's nothing here, we would return. Check 4, there's nothing here, we would return. Check 3 now. 3 is equal to 3. We would now add 5 into here. So same steps as I showed you right here. And then this is a vector within 3. So essentially, yeah, like this. Sorry for the crude drawings. Let me color this differently. 3 and then 2. So 2 is a vector. Uh-oh, let me do this. 2 and 3 are a vector of 1. 3 is just a vector of 2. 5, 4, and 3 are a vector of 3. 2, 3, and 5 are within the children vector of this current 3. So essentially, this is what uh this is doing, the add child to a node parent. Now within the public, like my tree videos before, we're just gonna make a method, a constructor method for tree. So tree root root, and then make it null. So every time we create an instance of tree, the root is going to be null. And then I forgot this. Then we're going to say void add single node. And all we would do is check if root is equal to null pointer. So if the root is empty, root is equal to, sorry, we have to pass in an integer value here. Root is equal to a new instance of node, and then just pass the value. Else add single node, pass in the root, and then pass in the value. So here what we are doing is if make this looks quite big. So here, if the root is null, r equals null. If the root is null, we would check here. If it is, root is equal to a new instance of node. So r is equal to, say we wanted to pass in one, r is equal to one, and it's going to be a node. So this is going to have a vector within it, a child vector within it, within the one. If root is already full with one in it, we would enter the else statement, recursively call um, this private method within the tree class. I send root right here, and then our value, say value is 2. Um, recursively call the root, and then the uh, adding the root and then adding the value. So 2. Um, say value is 3. Just we're just adding it to all of these new nodes to the vector of 1. Um, so yeah. Now for void add child to a child node to parent, int, we're going to pass in an integer parent value, integer child value. Again, we want to check if the root is null. If it is, we pass in the parent value as a root, and then the child value to the child vector of that parent node. So if root equals null pointer, root is equal to new node parent value, and then root dot children dot push back new node child value. So essentially the same thing. If root is uh-oh. If root is null, and we're going to pass in 1 comma 2 parent and then child node, root is equal to 1 now, and then we're just immediately passing 2 into the vector of um this parent value of 1. Else what we're going to do, wrong bracket. Else we're going to pass in recursively call add add child node parent. We're going to pass in the root, and then just keep on passing in the parent value and the child value. And then this is going to do all of what I explained up here before. So yeah, that is essentially it for the tree class for this n array tree. I'm going to real quick copy and paste a print. I'm going to copy a print um uh print tree so you guys can see how that it actually works. So yeah, okay. Um, not gonna lie, I didn't make this. Um, but here it is if you want to copy it. This is going to print it in order um to make it look like a tree. Um, so put this in the private area of the tree, and then within the public, it would be a void again. Void print tree, and then wrong brackets again. Print tree. We're gonna pass in the root, empty string, and then true for the bool. Essentially that is it for this. Uh, so yeah, let's create tree. we're going to start off by saying tree dot add single node of, let's say, 5, tree dot add single node of 3, tree dot add single node of 4. So since our current tree's root is null, 5 is going to be our new root. Um, sorry, 5 is going to be our new root, and then 3 and 4 are going to be within the vector, the child vector of 5. So now we're going to say tree dot print tree, and then run it. Oh man, what's going on? Add single node. Sorry, I kind of messed up the add single node. What we do here is I just had forgotten to do node point to the child vector, and then push back. Um, we're just going to be pushing back new instance of node um, value, new node value. Um, so forget what I said before about the add single node. What we're doing here is um, first we're going to check if the root is null. If it is, we just create a new instance of node with the current value that we pass in, and then root is going to be that value. So in this case, since when we first create tree's root is going to be null. We're passing in 5. 5 is going to be the new root of this tree. And then else add single node, we're going to pass in root. So the node, this node right here, and then our value of 3 come into here, which is this one, pass in our root node, which is has the value of 5, and then pass in 3 right here. Node, so node is essentially just saying roots children vector, and then push back the new value. Uh-oh, not this. The new value. So yeah, I kind of messed that up. Sorry about that. Um uh yeah, it was essentially just going to be infinite recursion if I just had it the way I had before. So like I said before, root in this case, root is currently null. We're going to pass in 5. 5 is our new root. When we pass in 3, we're going to where is it? Come here. Um, root is has 5 in it, so we don't have to make a new root. We're gonna do the else statement, which is recursively calling this private one right here. Pass in root into here, which is the 5, and then our 3. So 5 comma 3 root, and then go to root's children vector. Remember that this has a vector, and then just pass in 3 into this vector. And then same thing with 4. Come here. Root is not null. Else come up to here. Pass in root and then the value of 4. Root, which is the 5 children vector, which already has 3 in it. Pass in a new instance of node with 4 in it. So now 5 has 2 children nodes within its vector of 3 and 4. So if I run it now, there we go. As you can see, 5, 3, and 4. So imagine these two being in the vector, how I'm showing here. So yeah. Sorry about that error before. So then tree dot add child node, we can pass in a 5. Let's just for an example, 5, and then a 6. And then tree dot add single node of 3, and let's say an 8. So what this is going to do is going to search the tree looking for 5. If it finds a 5, it's going to add a 6 to that current child node, current node's children vector. And then here as well, if it finds a 3, it's going to add an 8 to the current to the current node's child vector. So if we run this now, as you can see here, um, we searched for a 5 and it just added a 5 to it just added 6 to the main root because this is the only 5 within the tree. And then it searched for the 3 and then it added an 8 to this 3 because remember this is like a mini root to this root. So this has its vector as well and just added 8 this vector. Now say if we wanted to add tree node dot add, let's say 8 and then 3. Let's use a different number, 10. Now what this is going to do is search for an 8 within the tree and then add the 10. And if we run it, 8. So it searches uh, the nodes within this current vector, searching for a 3. If it's not searching for an 8, then it searches this um, vector for an 8, this node's vector for an 8. We found an 8. Then it searches this, sorry. Then it checks if this value is equal to the node that we pass in. It is. So we pass in 10, comes back 1, 2, checks this one. In this case, it's null. There's nothing with no nodes within this vector. It's null. So we just return. There's nothing. We don't have to do anything else. Yeah, that's essentially it for the n array tree. This is all the code for it. Hopefully y'all understood and it made sense. I did have a couple hiccups up in there, but um, I did I did go over them and I did catch them. So sorry about that. Hopefully y'all understood and this made a bit of sense to y'all. Thank you for watching. See ya.